Hey everybody, this is Larry. This is April 25th, and let me try to do a random premium problem today. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's bonus Larry problem. 2473. Minimum cost to buy apples. Okay, so you're given some graph. Okay, 2D, a bi-directional road from A to B with the cost. Okay. You can buy apples in any city you want, but some cities have different costs to buy apples. That's fine. Okay. Apples of I is the cost of buying one apple from city I. Okay. You start in some city, and you eventually want to buy one apple from any city. Okay. And then you have to return. But wait, what? So K is on the way back or something? So you... Alright, let's take a look at an example then, because I was doing okay until this last part, where you have to return, but then all the roads back have to multiply by a given factor k, which is just weird. I mean, that's fine, but then it's just weird, maybe. Okay, start at city 1. Okay, so you want to... So k is 2, you have 4, and you want to buy an apple. Oh, you have to do it for each... for each city, not just one given city. Okay, that part I don't know if I would call it misread. I just made an assumption. Okay, so start at 1, you go to 2, you buy an apple at 2, and you go 2 to 1, so 4 times 4. I mean, yeah. Yeah, I mean, I think that I think it's just a little bit weird. Let me take a look at the constraints. Constraints 1,000. The thing that I was looking for is that there are also only 1,000 roads, so V plus E is probably what you want, which is a breadth first search type E stuff. Or maybe not V plus E, sorry, because these are not they're rated, right? So yeah. But I don't get the idea behind K, to be honest. Because if all the roads are cost the same, then you just kind of do the shortest distance, and it's like K plus 1, right? Times the cost or something like this. So that doesn't really change anything to the problem, except for like, I don't know. It's just very weird. So okay, so but that said, given that there's n of these, we can do Dijkstra in V log E. But then if there's V of these, that would be a little bit different, right? Bi-directional row. Okay, let me think. How do we get... I mean, I think a naive reading of this is that we just do the shortest path, right? But it would take V cubed to get all pairs shortest path. I'm trying to think if there's a early termination thing, right? Because if you sort everything by cost, if you sort everything by cost, then in theory that is a limiting factor. But I don't know. Why is this? Did I miss something? So basically, so you could store all the shortest paths, but because V log E is doing 1 Dijkstra. Right? So it'll be V square log E, which is like 10 million, which is a little bit much, to be honest. At least in Python. Maybe in C++ is a little bit, maybe it's fine. And I'm just like struggling because I have Python constraints in my head. How do I like them apples, huh? Don't really know, to be honest. All the other parts is fine. Can I go backwards? Going backwards don't really mean anything. Because we have to do it for everything anyway. Let's say you want to say so 42, right? All pairs shortest path. Can I do them together? No, it's the same. It should be the same. Huh. Man, I'm really struggling with this one, even though it's only a medium. You start at some city part is always weird because they didn't really specify. It should be from every city, but it's just like very awkward that I read it at the very end and then look at the example. But so it seems like what am I doing? What is I'm trying to think whether I can use something like what is it called? Bellman Ford or something. Oh, is it Bellman Ford? Or something like that, to take advantage of the fact that Y is low. But let me double check that. Bellman Ford. It's been a while. No, Bellman Ford is still single sourced. And it's still V times Y. So that's still going to be too slow to one for everything. Wow, I'm just like really struggling, even though it's medium. Unless I'm, Okay. I mean, I think there are other strategies that I'm playing around with that's kind of related. Almost like a minimum spanning tree, but not really. But because okay, let me talk about what I think, right? And this makes it kind of hard, to be honest. I don't know if this is the right way because I feel like, and this is maybe just me overthinking it, but sometimes I feel like medium problems are like pretty straightforward. So anytime I'm doing something complicated, I'm doubting myself a bit. But I think this one, for example, by definition, one starting city will be it's the best place to buy the apple, right? Meaning that in this case, if you start at city 2, you want to buy, you don't need to go anywhere because it's always the cheapest. So then now, maybe you expand from 2 to go, okay, what is the closest thing, right? So then from 2, you go, okay, the next is 1, and then 1 you have 2 choices now, because by definition of greedy and shortest path, you go, okay, well, 1 can either buy from itself, or it can go to 2, right? By the definition of how we sort these, by the definition of how we sort these, in theory, you know, either to, well, in theory, we'll go 3 first, and then eventually go 4 first. Basically, we're saying, okay, 4 can either go to 2 or go to 3. You know, basic things that we've seen because they're cheaper, and taking that path. And basically, for example, for the number 4, either you by the definition of the order that we structured it in the Dijkstra way, when we relax that node, we either, for that node, you either buy it here, or one of the places that you've already seen, right? I think it is just Dijkstra in that sense, but I think I could generalize the formulation a little bit. Sorry that this is so long, because I really don't have the intuitive idea, but the idea is that, okay, we put everything into the array. So okay, let me I think I don't know if this is right. It is greedy in a way, but the idea here for me that I wanted to do is that we put it in Dijkstra to, as part of a thing, to determine the order. I think the idea is that for each node, we connect it to one master node, with the weight being the cost of the apple at that node, maybe. Don't know if that's true. But that's, I don't know if that's quite true, to be honest. Or I'm just like doing something funky. Right. Okay, for example, the way that I want to write it, I'm just thinking in my mind. I don't know that I'm doing anything productive in my mind. I'm just going through a lot of examples in my mind, like calculating, if you will, whether I'm trying to find a counter example to what I just said. But I don't know if, you know, yeah, don't know. Right, and then the idea here is that we push to the heap this H thing, and then the cost, the node, and that's it, I guess. Right? And then maybe just apple, oh yeah, no, that's already in here. Yeah, and then here we also try like do a best array of, and that's just equal to apple cost, right? This basically is saying that if we didn't copy any, or everyone stay put, that's how much it would cost, right? And then here, then while length of heap is greater than 0, we have C index is equal to heap q dot heap pop of h, right? If best of index is greater than, if it's less than C, or if C is bigger than it, we continue. That means that we already processed this. Otherwise, for v in adjacency list of index, if best of index plus this is actually v and c, that's why I'm missing, or cost, because we already have this c, so let's just call it d for distance. Terrible, but it's cost times k plus 1, because you have to go back and forth. If this is greater than, or this is less than best of v, then we set best of v is equal to that thing, right? And then we push it. Best of v, right? And then we just set up best. Oh, is this one indexed? Yeah, it's one indexed, fine. I don't know that I'm giving, I don't know that I have that much confidence in these small cases, but I'm going to just submit it. I kind of, this is kind of a hard problem, to be honest. Don't know why it's so fast, relatively, but I mean, it is a very basic concept. The idea is that this basically becomes the shortest path from one master node, where the cost of the edge from that master node is the cost of the apple, right? So I'm going to over the complexity, it's not that interesting. This is very standard. This is very standardized. So yeah. But basically the idea, and I'm just pulling up the drawing pad, I'm trying to find my pen for the drawing pad, is the basic idea for this one. I kind of like it. It's kind of hard for a medium, but maybe not anymore. I don't know. Things keep getting escalated, as you know. But yeah, let's say you have something like this, right? The idea here is that you actually draw a master node. Let's just say in this case, I'm just going to call a Larry node. Why not? That basically, you know, and there's some cost of 1, and then now you draw a Larry node from here to here, here, and here's the visualization, and then here is you move the cost to the edge, and then everything is just Dijkstra, right? Why is that? Because basically you're saying from this Larry node, it costs C, I mean, and obviously you have to times this by k plus 1 or whatever, because you have to go back and forth from there, so the effective cost is higher. But basically you're saying, okay, right, for me, so basically what, from here you get a shortest path spanning tree, and this shortest path spanning tree represents going up to the root, the node that you are going to buy from, right? Because basically this is, you know, given this, the example one's input, also double checking that I'm showing it on screen because I made that mistake a lot, is that, you know, the actual shortest path spanning tree looks something like this, right? You have this one, and then this one, I think this one and this one, right? So that's the shortest path spanning tree. And basically, the node that, the node that the Larry node is connected to is the one that we're buying from because we're using the C2. But yeah, I mean, this is a very pretty problem. I don't know that I'm explaining it quite well in the reduction or the reduction. Yeah. No, I mean, it's pretty. This is standard Dijkstra, so it's relog ye. Or the way that we implement it is relog ye anyway, which should be super fast because we only have 1,000 re, and ye is also only 1,000. Yeah. Anyway, that's all I have for this one. Let me know what you think. Let me know if you have any other solutions. I guess let me click on this real quick. Mine is mine reloggy? No, I don't think this is I don't think mine's re square. Did I mess that up? No, we only pop once. Aggregator should be reloggy. You do sort of thing. Maybe I'm confused. What do people say? This is really like not. How do people get upvote for this? I guess there's only one more upvote. There's an explanation. BFS using Dijkstra. That's not really. Like that's just not how this works at all, but okay, fine. Okay, this is not really an explanation, but I mean, I think there is like other formulations of the problem for sure, but I feel like the way that I visualized it is probably the cleanest way. And I think one thing that I would learn from that also is just that, sometimes there are a lot of transformation of these problems. Whatever helps you visualize it the best, then you can kind of implement them in a very simple way, right? Because after I kind of did do that, everything kind of, like it took me like, a minute to write, even though this was a very tricky problem to solve, and I took like 20 minutes in total, including explanation. But yeah, anyway, that's all I have for today. That's all I have for now. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.